I have an example of a single replacement reaction from your guys' worksheet. Part of this example is from number 5 on single replacement worksheet. I'm going to walk you guys through how you should write out an equation and charge balance the equation so that the compounds are charge balanced before you even consider doing the mass balance using coefficients. So I've got the two directions at the top. First, we're going to write the balance reaction for copper reacting with iron 2 sulfate. You should pause the video and try to write that reaction totally balanced before watching the rest of my video of me doing it. So I'm going to start by interpreting the words into the formulas and the elements. For solid copper, we've got Cu. That's not a 4, that's a C, U. I'm going to put S for solid. Plus, when it says reacts with, we mean plus. Iron 2 sulfate. I know iron is Fe. Sulfate ends in ATE. It's an 8. That is a polyatomic ion. So you have to look at your polyatomic sheet or Google sulfate polyatomic ion, and you'll find out that sulfate is S capital O 4. This would be a good time to stop and go ahead and do the charges. From the directions, I know this is iron 2, so it's going to be a +2. I looked on my polyatomic sheet or Google and found that sulfate is a -2. So already, iron 2 sulfate is already charge balanced. Now, if they react, you guys have to understand during a single replacement reaction, the single element, like copper, is the only thing that can react and interact with this compound of iron sulfate. Since copper is a metal and tends to be positive charge, it's going to swap spots with the iron. And the iron is going to come out of the solution and become uncharged regular solid iron. So I'm going to go ahead and draw Fe. Now I'm going to do the swap where the copper has donated electrons to iron. Now copper is charged and teams up with the sulfate package. Sulfate is still -2 overall. Now in the directions I told you that note copper becomes +1 after the reaction. Therefore, copper 1 sulfate currently is not charge balanced. If I draw that correct, I drew it +1, it's +1. It is not charge balanced. The only way to make that charge balanced is by adding a subscript. Subscripts charge balance. So I'm going to put a 2 in there. Now copper 1 sulfate is charge balanced. So now you guys got to make sure you balance for mass at this point. If you want to, you can use the T-chart method. I'll model how to do the T-chart method for reactants versus products like I've been doing in class. Reactants, products. I'm not going to worry about the copper out front, and I'm not going to worry about the iron because those are solo independent elements, and they're easy to fix with coefficients if I have to later. I'm going to worry about adding up all my sulfur and oxygen first. On the reactant side, I have 1 sulfur. On the reactant side, I have 4 oxygen. And I'm going to go ahead and just go down the list. For my iron, currently have 1. For copper, I currently have 1. On the product side for sulfur, I've got 1 currently. For oxygen, I still have 4. For iron, I have 1 currently. But for copper, I have 2 because I had to charge balance it. I had to add an extra copper. So the only one that's out of balance right now is the copper. So luckily, the copper in the reactant side over here is solo by itself. So this is an easy fix in this case. If I put a coefficient out front of 2, I now have 2 copper, and it does not affect anything else in the reaction. So now this becomes 2 copper. Now it is charge balanced and mass balanced. If you paused the video earlier and tried it, hopefully it matches up with what you predicted. If it does not, you need to go back and rewatch where you made a mistake versus where I made my decisions. I'm now going to attempt to do the prediction example at the top where it says second. Predict how much copper is needed in the reactants to produce 43 grams of copper 1 sulfate. So this is where we need to use the ratios built from the package masses of either the elements or the compounds in the reaction. So what I like to do is I'm going to underline the items I need. When it asks how much copper is needed in the reactants, I'm going to come over here and underline the copper because I'm going to need to add up all the mass for the copper. I'm going to skip the iron sulfate because it's not necessary for my prediction. I'm going to skip the solid iron because it's not necessary for my prediction. However, I do need to add up the package mass or the package weight for copper 1 sulfate. In class, we've just been adding the masses up below the reaction. Since I have 2 coppers, I know I have to take it times 2, but I am not going to multiply the times 2. I'm going to leave it together as a package for my unit multiplier ratio. On the periodic table, 1 copper has a mass of 63.55 grams. I'm going to put parentheses on here and use this in my unit multiplier reaction. Now for copper 1 sulfate, I have to add up all of these because the whole package has a mass. For copper, since I have 2, I got to take times 2. If that 2 is out front as a coefficient, I would not complete this calculation at this time. I would leave the 2 out front like I did the copper over here. Each copper is 63.55 grams. But then I also have a sulfur. If you look on the periodic table, sulfur should be approximately 32.07 grams. Oxygen, I've got 4 of them. And if you look on the periodic table, oxygen should be about 16.00 grams. Now for this package, the combo of copper 1 sulfate, you need to multiply and add these up carefully. So you take 2 times 63.55, add it to the sulfur's 32.07, take 4 times 16 grams, and add those up carefully. As long as I didn't make a mistake and do the order of operations correctly, I got the weight for copper 1 sulfate to be approximately 223.17 grams for copper 1 sulfate. Now remember, people might be asking, why do I keep calling it copper 1 when there's a 2 down here by the copper? Copper 1 is just the charge a single copper would have in this case. The 2 just says I needed 2 previously to cancel out the sulfate charge. So I'm going to have to use this guy to build a ratio. And I'm going to use the copper to build a ratio. Now, if you go back to the prompt, we want to know how much copper we're going to get, or excuse me, how much copper is needed to get 43 grams of the copper 1 sulfate. So I'm going to use the classic unimultiplier strategy. Start with what I have in my possession, and that's 43 grams of copper 1 sulfate. And I want to convert from grams of copper 1 sulfate back over to regular copper to see how much I need to react to get 43 grams of the copper 1 sulfate. So I know down in the denominator, I'm going to have to put grams of copper 1 sulfate and steal the reading from our little recipe in the reaction. So I know it's true that I need 223.17 grams of the copper 1 sulfate according to the reaction to make this thing work. But also, I know the recipe calls for copper in the 2 times 63.55 from the reaction above. The grams in copper 1 sulfate cancel in the top numerator and cancel in the bottom denominator, leaving me with the grams copper I wanted to get. I'm going to do this in 2 steps. I'm going to simplify across the top and simplify across the bottom. So if you take 43 grams times the whole package of 2 times 63.55, you should get approximately 5,465.3 grams of copper. But I also got to bring over this 223.17 grams. Well, it used to be grams copper 1 sulfate, but it got canceled. So bring that over. And we're just doing classic unimultipliers we've been doing since physical science and throughout chemistry off and on throughout the year. So if you simplify those, I got approximately 24.5 grams of copper is needed in order to get the 43 grams of copper 1 sulfate. Make sure you go back and rewatch the video or try this on your own. There are other videos on Canvas that I loaded for how to balance just basic formulas, how to balance a couple reactions. The cumulative nature of needing to know how to balance equations is based on how well you can name a compound and look up the charges and charge balance these things. Feel free to touch base with me tomorrow